So myself Komal Namba. Today we will gonna discuss basically what is natural language processing, how it comes into the picture, what are the amazing things we can do with the help of NLP and its techniques. Basically, as we know, just imagine how if we can talk to the machine. We are human, and like if I want to talk, I can just simply talk with my system, with my laptop. This is amazing thing, right? Now, uh just just go to the history part, I can say. Let's go over there. I can say, if anyone remembered the World War II, after basically the World War II, this natural language processing comes into the picture, I can say. The people having a thought how we can translate one language into another, because if I am able to understand English, Hindi and XYZ language, but if I'm not able to understand German and I want to talk to any person who is not able to understand the language I am getting, so over there this machine translations comes into the mind. What if we can develop something like this, a system will gonna, just convert the language, just translate the language, whatever input I am giving into any of the language, that input will be gonna converted into another language, and that language is, easily understandable by the another person. So this is the beauty of NLP, I can say, with the help of deep learning AI, the techniques which we have. So basically NLP, the natural language processing, it can be a thought of intersection of computer science, artificial intelligence, which helps us, to understand what computer will gonna understand and how the human language, the natural language, will gonna manipulate. Okay, so let's go to the definition. I can say what is NLP, and what Wikipedia says, what scientists says to us. Okay, so today in this session we will gonna discuss the NLP, the introduction of NLP, the idea behind NLP, I can say, and the main taxonomy, the pre-processing methods which are required for the NLP task, the feature generation which is required to develop the input and to extract the features, the important task using NLP, using natural language processing. So there are beautiful, amazing things which we can develop using this technique, and the frameworks supported by Python language, over where we can develop whatever we want to. So let's jump to the definition, I can say. The natural language processing is a field of computer science, that is artificial intelligence, or also we can say the machine learning and the deep learning. And as we know, the languages come over here, so we can say that linguistic languages are come in a picture, and the interaction between the computer, the system which we have, and the human, the natural language. So this is especially a process which a computer extracting, the meaningful informations from the text, from the input, and it will gonna give the output of a natural language. So as we discussed the history, like from where this natural language comes into the picture. So this is an example, or we can see the root of natural language dates to the 1950s, when Alan Turing first devised the Turing test. And the objective, as we know, of the Turing test was to determine whether a computer was knowledgeable based on the ability to interpret and generate the natural language on the basis of intelligence. So as we know, why the artificial intelligence is called intelligence, why robots are intelligence, and why the data scientists are intelligence, because we know the magic of AI, and we know how we can develop the things beautifully. So as we discussed, the like how NLP is combined and what we can do with the help of natural language processing. Even even we have immense amount of study development, everything has happened in this field, and one of the most demanding field right now, because all the translation we used to do on Google, the language translation, the classification is happening over social media websites. Okay, if anyone remember, like we used to tweet lots of things on Twitter, we used to comment lots of things on social media. Our life is revolving over there. Okay, nowadays when COVID comes, everyone is tweet anything, whatever they are feeling. The Facebook comes in a picture, the Instagram and everything. Even nowadays business are happening over there. So the comments we are the user of that platform, the comments we used to do are nothing, they are the text. And using this NLP, we can classify that, we can analyze the sentiments of that. Even there are lots of different examples which we will gonna discuss further in the session, how different magics can be happen. So let's discuss the NLP and its processing, how the data comes, from where the data comes, how we can treat the data, what are the pre-processing techniques we can apply to the data, and the feature extraction techniques. And after that, as we know, the machine learning and deep learning things we know very well. So we know, there are the few steps. We have the raw data, we need to pre-process the data, we need to extract the features, sometimes we need to generate few features, then we need to split the data into training and testing, and after that the model training and model building and model fitting comes in the picture. So basically this NLP is having two parts, I can say. The very first part is we need to pre-process the data. Suppose, let's take an example of Twitter. The tweets are on the Twitter. Okay, everyone is tweeting their thoughts, everything. Some tweets are good, I can say. They have some positive impact on the human brain. But some tweets are having negative impacts. Even some tweets are having some bad words which impact negatively, I can say. If anyone can read, the mood of that person can be changed or something like that. And once this pre-processing of the data is done, as we discussed, we will gonna jump to the algorithm part, that is the modeling part, the models which we will gonna fit. Okay, so this is the libraries, the pre-processing techniques and tasks, which is basically the part of NLP. Firstly, we will gonna discuss the pre-processing task.
Komal, sorry to interrupt you, but
Yeah.
some of our participants are telling that they hear two voices. So have you logged in from two devices?
No.
Okay. Okay, you can continue. I'll check with them.
Okay. If still they have an issue, please let me know. Like everyone is having this issue or only some of them?
Almost 3 to 4 people are having this issue.
Okay. Please let me know. Please stop me if they still have that issue.
Okay.
Yeah. Thank you. Okay, guys. Let's come to the text pre-processing part. So in the beginning, the tweets we used to do on the Twitter, the comments we used to do on any social media platform, even on Amazon, if we bought any product. If I like the product, I'm gonna tweet. I'm gonna comment, this product is good. This is having amazing result. The price point is good. But what if the product is not good? If the services are not good? Anything, if I'm not able to like, or if anything which I dislike, what I'm gonna do? If I bought anything from Amazon, Flipkart, Nykaa, Myntra, whatsoever, any e-commerce, what we used to do, we bought a product and we used to just give a feedback. Even as we know, we used to book hotels and flights and everything from Make My Trip. Now if you are the user who used to uh, regularly book the hotels from that website, what they will gonna do, they will tell us, please give your feedback, share your photos of the hotel you booked, the room you booked, please give us the feedback, and they will gonna give us the point which we can redeem in our next booking. So even they want we need to tweet something, we need to give our feedback, and that feedback helps other person to decide whether they have to book that hotel or not, whether that person need to or you should buy that product or not from any e-commerce thing, or even from a Twitter. If a movie is having the reviews which is good, then we have some we have some support system. Okay, let's go for this movie. But if you want to go for a movie and you saw on any social media platform or anywhere that movies have some some bad feedbacks, I can say some negative feedbacks. Nowadays the web series are in the picture, it's a trend of web series, so like that. Basically everything is dependent on the text we are giving on social media, on e-commerce sites, on everywhere. So that message or that comment, that tweet, anything we are giving is a raw thing. We are used, it's is it compulsory that everyone knows grammar in a high level? If a person is typing something, it might be happen that grammatical mistakes can be done. It might be happen some words are in a lowercase and some words are in a uppercase. It might be happen that we used to add emojis right on nowadays. It's easy to describe my sentiments, it's easy to describe my emotions by just putting that smiley at the end of my text. Everyone can be able to understand what I want to say using that small smiley in the end of my sentence. So everything kind of this, the the smileys and everything is in the raw text. So the raw text which we have, we need to clean that. We need to remove the URLs, the hashtag, the the emojis which we have, the @ marks which we have on, especially on Instagram, on Twitter, and everywhere, if we tag any of things. So basically we need to clean that text. Once we have the clean text, that is once we have the pre-processed text, we can apply the pre-processing techniques and we can extract the features from that. If we are able to extract the features now, then only feature selection will be gonna comes in a picture. The same flow which we used to follow in machine learning and deep learning, it will be gonna follow in NLP also. So let's take an example. As we discussed, we will gonna take an example of tweets from a Twitter. Now in a tweet we are having lots of things. So the very first step we need to do is we need to clean the text. We just need to clean our raw tweets, and we need to remove all the unnecessary things which are actually not required to analyze. If okay, let's take an example of sentiment analysis using tweets from the Twitter. Now the URLs are actually not required to analyze the tweet, whether it has the positive sentiment, whether it has the negative sentiments, and whatever the things are happening in the tweet. The words having the relations between each other, if all the random few words are putting together to form a sentence because they have relation with each other. So this is how the cleaning basically happened. Now we are having this text cleaning pipeline, which having the few steps, I can say. The very first step is to clean the text. After that we will gonna tokenize the text, and we will gonna remove the stop words. Yeah, yes, do you want to say something? Hello? Am I audible to everyone?
Yes, you're audible.
Um,
Komal, you can go ahead. We'll have the Q&A at the end of the session.
Okay, actually he raised his hand, that's fine. Okay, no problem.
Okay.
Yeah, so in this pipeline, in the screening pipeline, let's come to our discussion again. The first step is cleaning. The second step is tokenization. Don't worry, guys, this heavy words are damn easy. We will gonna discuss every word. Then we will gonna we will gonna remove the stop words. We will gonna POS, that is tagging. We will gonna recognize the entities, and we will gonna stemming elementization and everything. So first step, let's do the very first step, I can say, That is, we need to convert the text into lowercase. Okay, now if my name is written in in uppercase, in a lowercase, or the first letter, if my name is Komal, then the first letter K is written in uppercase and rest of the letters are written in lowercase. Does that gonna make any difference? The name should be the name. If I wrote a sentence, my name is Komal, then Komal is my name. That's it. It not gonna give any kind of difference, if it is written in any of the case. So the very first step in the screening, in this pre-processing of NLP, we will gonna convert everything in a lowercase. Over in the slide, we can see the example very well. The name of country, that is Canada, is written in a different way, and we will gonna convert that in a lowercase. That Tomcat is written in a different ways, I can say, and we will gonna convert the same thing. As even you can see how we can do this. We are having a function in Python, that is sentence dot lower. The sentence is the thing, or the data is stored, I can say. So basically, this is the very first step to convert the things. Now, the next is tokenization. Now, what is tokenization? Tokenization is a pre-processing step, and tokenization, that means what? It will gonna split the sentence into single word. Token, that is each unit, individual token, that is a single word. Now, as we know, we are having NLTK library, that is Natural Language Toolkit library in Python, which helps us to do all these pre-processing techniques in the NLP domain, I can say. So let's take an example of this thing. That we love NLP, or I can say I love NLP, and whatever the sentence we have, my name is Komal or whatsoever. Basically, we will gonna split that sentence into each word. And the most important thing, we need to install this library, guys. So as we know how to install the library, we need to import that. If you are using the terminal thing, the VS Code, you need to pip install that thing. And now the tokenization, which we are just discussing, having two different variety, I can say, the types of tokenizations, having the sentence tokenization and word tokenization. Now the word tokenization is nothing, whatever we saw just over here. Now the we love NLP, we split the sentence into word, is a word tokenization. And the sentence tokenization, I can say, if we are having a paraphrase, the whole paragraph, I can say, so in that case, you will gonna split the whole paragraph into the number of sentence it has. So as we know, the full stop, the comma, and all these things are helpful to split the sentence. So let's take an example of this sentence. As we can see, it has basically 3 sentences in a small paragraph. So this is the sentence tokenization. Now just remember, the beginning of the sentence is having some commas, some full stop and everything, because this is the next thing which we will gonna discuss. Okay, so the next thing is punctuation removal. Now how punctuation removal can be done and how it is important. Okay, now the sentence are not gonna understood by the machine will gonna understand something from a word. That thing we will discuss further on, but we need to split the whole paragraph, the whole sentence into words, and we will gonna split that. So even that commas, that full stop, that semicolons, then inverted commas, that brackets, everything is not useful for us right now. So what we will gonna do, we will remove that thing. We will just take the sentence or the word, the collection of words, the list of words as it is, and we will gonna remove all the punctuations from our tweets, from our paragraph, I can say, anything. So, okay, now the very next step is the stop word removal. Stop words, is the word which we will gonna use very much in our sentence, I can say. in our paragraph, if I am writing a 1 page of answer, I can say, or anything if I am gonna writing. So in that case, I, me, myself, you, our, this kind of things we used to we used to repeat, even if I'm talking with you guys. So there are a few words I'm going to repeat again and again and again in any conversation. Does they have most important meaning, I can say? If you come with any other thing, okay, if the words, if I can say, there are two important parts to natural languages. So r and two are important, but with the words itself, but they will not gonna change the meaning if I'm gonna remove that. So let's remove that stop words. Now if we remove the stop words, basically what we will calculate the number of words which we have. And how we will gonna remove the stop words? With the using same library, I can say, the which we use for previously, that is NLTK. Now once we remove the stop words, I can say the cleaning of our text, I can say, is almost done. The only few steps are remaining, that is stemming and limitations. Don't worry guys, this is the theoretical part, and the outputs I'm using over here to explain, we will gonna implement the same thing in the end of the session for sure. And while the implementation, you will gonna get the clear ideas when the result is displaying in front of you. So now studies, I will do my study, I will complete my study, and all and all. Do this things will gonna make any changes? The study is study. Yeah, the changes of the past tense and present tense and the future tense, something like that. Okay, so what stemming is do, it will gonna remove the suffix. And what limitization will gonna do, it will remove the grammatical information. It will whatever the studies and studying in the any of the tweet, I can say, it will gonna take as a single word, that is study. And stemming, that will just remove the ending portion of, I can say, the ending part of any word. It will gonna convert studying into study and studies into study, that is I will be gonna kept over there. So this is also the part of cleaning of any of the tweets which we are gonna take for the sentiment analysis, I can say, or any of the paragraph for which we need to calculate the polarity, the subjectivity, and the if I want to analyze what are the reviews I am getting for any of the product. Okay, so now okay, if we are need to do stemming, then how we can do with the help of NLTK? As we know, we are having this library which is useful for us to do tokenization, limitization, stemming, and all that stuff. So basically we just need to give the dictionary of our words, the list of our words, the whole paragraph, whatever we want to give, in whichever way we want to give, I can say. Even if I'm having the CSV of all the statements or all the tweets, okay, if I extract all the tweets from a Twitter's URL and I stored all the tweets in a CSV, then I'm gonna give my CSV in the beginning, as we know. Okay, if I'm taking an example of Amazon review, I can say, okay, let's do the sentiment analysis for any of the Amazon reviews product, using any product, or by targeting any product. So we will gonna collect the data in any of the file, and in the beginning we will gonna give the path of that file. So let's come to the stemming portion again. How we can do this? It will just gonna convert doing to do, studying to study, identify to identify, and this to the. Basically it will reduce the length, nothing else. Okay, the next step is limitization. Limitization is nothing, it will it is a process of grouping together the different form of words, I can say. It will gonna children to child, child to child, dogs to dog, feet to foot. But as we can say, it will not gonna convert this to the and identify to identify. See over here, it will just reduce the length. In stemming, it will gonna remove the s portion from this, But in the limitization, this thing is not gonna happen. It will kept this as a this. Again, for limitization also, we are having the library that is NLTK. We just need to import the word net limitizer and we can able to do the limitizations. So once we are able to clean the raw text which we have in the beginning, the raw tweets, which has lots of things which are actually not required, the URL, the hashtags, the emojis, the punctuations, the IDR and all that stop words is not required to analyze the sentiment. Okay, so we will just remove that. We will gonna remove that thing. Then we will gonna extract the important information. And as we know, the information is nothing but in our language, it is feature. Features are having most important part, I can say, in the terms of training. The features having high impact on the target, on the output, and on the result also. So as we know, sometimes what we will gonna what we will gonna do, we will gonna extract the features, and it is also required in some cases that we will gonna create the features, right? Or I can say we will generate some new features from the data we have and the features we have. So let's basically discuss the feature extraction technique which we have in this thing. Now this person Andrew Ng, we everyone, like, you know, from the field of data science, we know him very well, I can say. And even you know, he has high impact. His knowledge and everything is having very good impression on our brain. So what he said about this thing: producing feature is difficult, time consuming, but it requires expert knowledge. So as we know, EDA is the most important part of any of the problem definition exploration, I can say, to train any model. You know, pre-processing of data, feature extraction, and everything is having the most important thing in our machine learning and deep learning, and just like in NLP also. So okay, let's come how many features we are having, what are the types we are having in our feature engineering, I can say. And basically, to analyze a pre-processed data, it needs to be converted into features now. And you know, it depends upon the usage. The text features can be constructed, we can generate or we can extract using these techniques. So as we know, we can see we are having some techniques for feature engineering, that is syntaxical parsing, then entity parsing, the statistical features, and word embedding. And they have some their features or their functions, their techniques inbuilt that. So over there we can use that. Now okay, some random words are you know, are combined and form a sentence. If a single word is given to you, what you will gonna understand by that single word? Okay, what is the meaning? As we know, you know, okay, if I am say submitted, what is submitted, to whom it was submitted? I just said to you submitted. Are you able to understand what is gonna happening over there, like how things are gonna happening? What is the meaning of that word? Actually, we just know the meaning of word, but if all the words are combined together, we are able to analyze what is happening. We are able to analyze the meaning of all the words which are combined to form a sentence. And they words, even that words are connected grammarly, they have the dependency on each other. So the figure which we are seeing over here now, it is nothing, it is known as the dependency grammar, and it is known as the dependency trees also. This dependency tree is having the dependency of grammatical words which were connected and having the relationship among each other to form a sentence. So this is how the parsing is happening in NLP. Now, if we jump into parsing now, then part of speech is gonna come in, is, you know, is will gonna come into the picture for sure. Now the part of speech tagging is actually, it is apart from the grammar relation. Every word in a sentence is also associated with the part of speech, I can say. Now, what is part of speech? It is nothing. The noun, the verbs, the adjectives, the verbs having different forms. It basically, we know, verb is having 6 forms: the past one, the present one, the participant one, sorry, the base one, and we have noun also, like any. And if okay, let's understand this by taking two simple example of two words, I can say. If I'm taking one word that is, sorry, one sentence that is, please book my flight for Pune, for Delhi, everywhere, anywhere, I can say. So this is my first sentence: please book my flight for Delhi. And let me take another example of another sentence, I can say, that is, I am going to read a book in the flight. Now the book word which was in the first sentence and the second sentence having different contexts, we know. The first sentence, in the word that in the sentence, that is book, that word is used as a verb. What was the sentence? Please book my flight for the Delhi. So flight and book, so book is a verb. And then second sentence which we have, if I'm not wrong, it is I'm going to read this book in a flight, right? So that book is used as a noun in the second sentence. The book word is same, but when it comes with different words and it forms a sentence, the meaning and the context is changed. Okay, so this is how the part of speech tagging is important in NLP to analyze any of the sentiments of any of the word, I can say, or any of the sentence, to analyze the sentiments of any tweet, any feedback, any comment over anywhere. Okay, from this snapshot we can say, I'm having a text that is, I'm learning natural language processing. Now what this POS tag, that is part of speech tagging, will gonna do, it will just gonna split the sentence into words and assign what the word is. Is it noun, is it verb, whatever the word is, it will just, it will just give the thing to us. It will just gonna give the information about each and every word to us, that what that word assigns. Okay, so the part of speech also having, the depth thing, like how we can do, we can normalize the data, the raw tweets, the sentence, the words, and we can do the lemmatization. Even we can improving the word based features. The word based feature is a nothing, it is a learning model that could learn different contexts of words when used words as a feature. So as we know, we need to improve the word based feature. So over this domain, I can say, in this feature, the word is the will gonna having the most important part of anything. So the word will be gonna used as a feature. However, if the part of speech tag is linked with them, the context is same, I can say, but it will gonna make it the most important feature among all the features. And we can remove the I think as stop words, which we discussed above also. Even the normalization and limitizations also are having the basic lemmatization process for converting a word to its base form, that is lemma, nothing else. And the stop words is also having the same thing. Now okay, we are having one another feature extraction technique, I can say, that is entity extraction. And over here, we will gonna extract the feature, that is entities, which are defined as the most important part, or I can say most important chunk of the sentence. Now it can be any, no, it can be noun, it can be verb, or it can be both. Even this entity detection algorithms are generally assemble models of rule-based parsing, the parsing which we discussed before. And it has the dictionary lookups, even it has the part of speech and dependency parsing also. So basically the application of this entity detection can be seen in the chatbots. even in the content analyzer, which will gonna analyze your content, which will gonna summarize even. So basically, it is a detection. If I want to detect what about this sentence, how good it is, if you wrote a paragraph and you want to give a title, so that thing should be detect first now. That thing should be understood first by the machine, by the system, to give a title of anything, I can say. So this is how this entity extraction can be done in our NLP. Now it has basically three types. Okay, the very first type is name entity recognition. The process of detecting the named entities. The person name, the location, the company name from a text. As we took the that sentence, I will book my flight for Delhi. So Delhi is the location name. And if we say that my name is Komal, then Komal is the name of a person. So this is the name entity recognition. Anything which is took as a form of person name, location name, company name, and etc. Now the next is even this NER, that is name entity recognition, having three blocks. It will gonna split the methodology, or I can say it will gonna split the task of this thing. It will gonna split in noun phrase identification. This step deals with the extracting all the noun phrases from the text using the dependency parsing, which we just discussed before, and the part of speech. Now the second is phrase classification. What are the phrases we are using in the text we have, and it will gonna extract noun phrases and classified into location, name, and categories which will gonna used. Now okay, so the next from this entity extraction, I can say, that is topic modeling. Now the topic modeling, I can say, it is a process of automatically identifying the topics present in the text, the corpus we have, the phrases we have, the paragraph we have, as we discussed. If a good topic model is result in health, doctor, patient, or hospital. If a paragraph is having this kind of names, this kind of words, I can say that doctor, something related to patient, something disease, and anything. So we can say ki, this paragraph is somehow related to healthcare. Okay, if I give any paragraph to the my machine learning or my NLP model, so and I want ki, I'm getting the title. I want a title for this paragraph in an output, and my input is the paragraph. So NLP comes in a picture, and this is how it will gonna do the whole pre-processing, the feature extraction, and using this entity extraction from a feature extraction technique. From that, topic modeling is a part. Guys, are you able to visualize the things? We are having the feature extraction technique in the top. In that we are having different techniques. In that we are having entity extraction, and in that we are having topic modeling. So are you able to understand how things are happening nowadays? A small feature is able to build a whole concept. That is, what is my problem definition? I am having a paragraph as an input, and I want the name of that paragraph or the title of that paragraph as an output. So this is the whole concept from that one technique of a feature. Now the next is we have is n-gram. Now a combination of n words together is basically called as n-gram, nothing else. Now n-gram, so we need to define the value of n. Okay, if n is greater than 1, I can say it is unigram. If it is equals to 2, I can say it is bigram. Or like that, we are having trigram. I think we are having only these three categories: unigram, bigram, and telegram. So this is how the feature extraction can be done. If and we can do the experimental analysis of results over this feature only, over this n-gram. If someone is doing his or her research now in NLP, then what that person can do with the help of this only one feature technique. It basically took the problem definition, the input from anywhere, from Twitter, from Amazon, whatsoever. It will apply all the cleaning techniques, it will apply all the feature extraction techniques, and after to analyze the result, how this feature is important to get the polarity of in every sentiment of every word, I can say. Okay, to get the subjectivity, how these things are happening, how this only one feature is having highly impact on the result. It can just analyze the things. Once it will gonna train the model by taking n equals n is greater than 1, that is unigram. Then it will gonna take n equals to 2, that is bigram, and n is greater than 2, that is trigram, and n equals to 3. That person can take this kind of examples and to analyze the result, the whole things in a experimental way, I can say. So are you guys able to understand how a single feature is important in our domain? Now okay, let's take an discuss the most important feature of the NLP, that is term frequency, and it comes into statistic features, that is TFID, and another part of that is density of features. That is nothing, density is count, variability features, I can say. And TFID, the term frequency inverse document frequency. TF is the term frequency, and IDF is nothing, it is inverse document frequency. Now TF-IDF is a weight model commonly used for information retrieval kind of problem definitions, if we are having. Even it has a aims to convert the text documents, I can say, into the vector models on the basis of occurrence of every word in the document without without even taking the ordering of that. It doesn't matter what comes first, it will just calculate the count of that word. Okay, now let's say there is a data set of having n text documents. So in that document, it will gonna calculate the word d, or I can say the study, whatsoever. It will gonna calculate, and how it will gonna calculate, we are having the TDF TF-IDF vectorizer in sklearn. We just need to import that using the feature extraction and the data which we have, and it will gonna calculate the count, and it will gonna give the result, and with the help of some mathematics techniques behind that. So this is the mathematics behind this TF-IDF, I can say. TF basically is the frequency of x in y. Now x is the word and y is the document. It will gonna apply some log function, it will gonna df by n, and n is the total number of the documents. So by the help of this derivatives and all that in the log functions, we are having the count of every word over there. Even if we want to understand in deeply, then the t is nothing, from that it is a count, and the d is the document. That's why we are taking n as a as a text document, like the number of the n number of I can say words in my document, or I can say text in my document. And d in any document d, that is the word which we are gonna analyze. So even the IDF, that IDF is inverse, that is logarithm of the ratio of total documents available in the corpus, the whole data set we have, and the number of documents containing the term t. The t is the word which we need to calculate, which we need to count in the whole document, I can say. So this is the basic example of TF-IDF. I can the demonstration. As we discussed, we can calculate it with the help of sklearn feature extraction technique. That is, we just need to import the TF-IDF, sorry, vectorizer, and we just need to pass the data we have, and we will gonna have the output for that. So this is the next feature, which as we discussed, it will gonna count the word, it will gonna count the punctuation, it will gonna count the sentence, even it will gonna count the specific word with specific relation, I can say. Suppose if I want to count the word that is related to data science, if I want to count a word that is related to healthcare sector, so in that case it will gonna help us. Even this feature might seem trivial, but shows a great impact in learning models. Okay, like some of the features as we discussed, it has the word count and sentence count and all that stuff. So the next thing is word embedding. Now this word embedding actually having the most important feature, I can say, the feature extraction technique, I can say. And the word embedding is the trending way to represent the words as a vector. Okay, now as we know, if we talk about image classification, whether my CNN will gonna take image as an input? No. What it will gonna take? It will gonna take matrix as an input, and it will gonna study the pixel values and do the rest things. If I am having an audio file, will my model will be able to listen that audio file and tell me whether it has positive sentiment, whether it has happy emotions or sad emotions? No. It will gonna take the features, the MFCC features of audio. It will gonna convert that audio in 1D vector, and it will having the value of frequency, the amplitude, the pitch of the voice of any person who is having the audio clips and all that stuff. So basically the point is how texts are given to the system. We have that 1D vector. Okay, so that 1D vector we will gonna give to our model. This thing is very much clear to us, right? So the aim of this word embedding is to redefine the high dimensional word features into low dimensional. So we can have some contextual similarity in the corpus, the data which we have. Even as we know, this word embedding is used in RNN, in CNN, in LSTMs, and everywhere. Okay, even in the some amazing models of NLP, that is transformer, the attention mechanism and everything, they are using this word embedding. Even if we are studying the graph techniques and all that, if we are working with graphs also, so that word embedding are there, but in terms of node. This word to vector is like we are using in NLP. In graph it is node to vector. Okay guys, let's continue our discussion. Till now, let's do a revision, I can say. Till now what we discussed in the NLP, how the text pre-processing can be done, and basically how the feature extractions can be done. Okay, so in the beginning we have the raw tweets, the raw text or anything, I can say. Next, what we need to do, we need to pre-process it, we need to clean the text. In that, basically we will gonna convert our text into lowercase. That is the very first step. Then we will do the tokenization. Tokenization is nothing, we will gonna split the whole sentence into words, that is word tokenization. And if we are having a whole paragraph, in that case we will gonna split the paragraph into sentence, that is sentence tokenization. After the tokenization, we will gonna remove the punctuations and stop words from the text which we have. Punctuations are nothing but the full stop, the semicolons, colons and all that. And stop words are the most repeating words in the sentence, that is like the, in, of, are, something like that. So we will gonna remove the stop words and we will gonna remove the punctuations. Once we are able to do that, the next step is stemming and limitizations. As we know, the stemming will gonna remove the suffix and the limitizations will create the grammatical information from the words, and it will gonna convert the words into the smaller word, I can say. The studying will be gonna convert into study. Now over here, if we completed this much steps, we can say the raw tweets are cleaned now. The raw tweets are pre-processed now. Once the tweets are pre-processed, we the data is pre-processed. We need to extract the features from that, and we have the parsing, the part of speech tagging over there. Once we extract that kind of features, we have the option of entity extractions, and that we have different options. We have tfidf option over there. We have the density of features is also there, that is also an option for us. Once even this kind of features are can be extracted, and the next thing that comes into a picture is the word embedding. Now, as we discussed till the text vector, that is word embedding, using the vectors that is converted from the words. And the very next step, even we saw an example of word embedding, that is just in the previous screen, I can say. Let's go to the previous screen to revise the things. We can just calculate the similarity between the two words. We can count the occurrence of that words in the sentence using this word to vector. Now we have one more method, I can say, for the basic models, the base models, that is GLOVE method, and it is unsupervised learning algorithm for obtaining vector representation of the word. The same way the words are gonna represent in the format of vectors. And as we can say that I'm having the whole sentence, the phrase, the paragraph whatsoever, that paragraph will gonna go to the input layer, the pre-trained vectors. It will gonna split into each word, it will gonna split in a tokenization way, in a token. And then after that, the embedding layers comes in a picture, and it will create the dimensional, and it will gonna create the co-occurrence matrix, which will gonna represent the pair of words and they're occurring in the whole paragraph, in the sentence, and all that. So even this algorithm, from where it gonna obtain, this is unsupervised learning algorithm, as we know, and it is developed by the researchers at Stanford University. And the aim of to generate or to develop this algorithm is to generate word embedding by aggregating global word occurrence matrix, that is uh, from where we will gonna generate that, of course, from the data which we have, the corpus which we have. So the basic idea behind this glow word is now glow word embedding is to derive the relationship between the words, the all the words we have in our corpus, and we need to derive the relationship between that, and we need to calculate the occurrence of that. Even the occurrence matrix is calculated by word to vector also, but this glow is useful to derive the relationships. Now there is one more model, I can say, that is BERT in NLP. It is very famous model. So that BERT is having its own its own embedding technique. BERT segments its input into subwords, and that subwords units will be gonna called as word piece. Even this word to vector and globe. So if I am going to compare these two methods, so as we know that word to vector is faster in the computation, in a computation, in terms with, if I'm gonna compare it with the globe, of course. So this because the word to vector is employed the negative sampling just by converting the softmax function to the sigmoid. As we know, these two are the activation function, and the conversion results in cone shaped cluster of the words all the vectors is having. And in terms of globe, these word vectors are more distinct in shape, and that's what make the globe slower than the word to vec. So this is how we can use this kind of methods, the globe, the word to vec, even the BERT embedding for the BERT models. Because as we discussed that these are the most important features, I can say, and the embedding is required to train to get the results. Now As we know, the NLTK, the sklearn, and everything are important for us, the frameworks that are important in NLP. And now let's discuss, the first thing, that is the important task which we have in NLP. If anyone remember, in the beginning of the session, we took an example of one of the application of NLP, that is machine translation. Okay, suppose if I'm saying a language which is not able to understood by you, so in that case, what we used to do, we will gonna just give that task to the Google Translator. So behind that Google Translator, the NLP is there. The NLP is the reason how machine translations, how language translations are happening. So this is one of the amazing example of NLP. Next is text classification. Text classification is one of the classical problem of NLP. Suppose you need to classify whether your email is spam or it is it is a genuine one. So email spam identification is a part of text classification. Even topic classification for any of the news is a part of text classification. The sentiment classification is also a part of text classification. Text classification, in a common words, is defined as a technique to classify a textual object, the document from the text, the corpus we have, the whole data we have. We just need to classify whether the whether the length or the size of data is too big, I can say. We just apply all the cleaning processes which we discussed. We applied the feature extraction, and after that the training will gonna happen. After the feature extractions, the features are extracted, the classify model will be gonna applied, the training will be gonna done. And once we are able to done that training, what we will gonna have, we will gonna predict what. Suppose I'm taking the example, that first example which we discussed in text classification, that is email spam classification, or I can say email spam identification. So in that case, what will be gonna happen, we will gonna classify whether that email is spam or not. We will gonna classify the emotions, the sentiment of a text, of a tweet, of a review of any product, of a comment on any e-commerce site. This is how the text classification can be done. And we have text blob library, I can say, the framework using which we can directly import the classifiers, the models which we have, and we can do the text classification using scikit-learn and all that stuff. Sorry. So the next example, let's talk, that is text matching and similarity. Now, one of the most important area of NLP is the matching of text objects to find the similarities. As we just saw, I think 2 slides or 1 slide before, in that word embedding, that data and science, we just calculate the similarity between that 2 words. So the important applications of text matching includes the automatic spelling corrections. The like the Grammarly and all that stuff. What they are doing? They are doing this thing, the text matching thing. And the next application, I can say, that is data duplication. If if I want to duplicate the things, if I want to find the synonyms of any other words, so it will gonna compare what I am finding, and it will gonna match the things. The number of text matching techniques are available depending upon the requirement which we have, basically. We can it is great domain, I can say, guys. You can do your research, you can you can find how many ways they have. In a mathematical way, there are one of the technique, that is cosine similarity, in this text matching similarity. And basically it is, of course, it is calculated the cosine value of everything, and it will using the term frequency and applying the cosine similarity to provide the closeness of the text, or I can say among all the texts in the document. So this kind of techniques we are having in this text matching. Now even text summarization, I can say text summarization is what it is nothing. It's like if I'm having a big paragraph of two big paragraph, or I can say I am having an article of 3 pages, and I don't want to need to read the whole 3 pages. I need a summary of the the whole description in a small way. So over there the text summarization comes into a picture. Even even any of you having a habit to read the research papers, we know the abstract is there. What is abstract basically, and what is it has basically it gives the idea to what the article or what the paper is about, to to us to understand the similarities, even in a better way, I can say. Now this text summarization can be done with GPT models. It is very powerful model, I can say, in the whole NLP domain. We can't train this GPT models in our local systems. We need GPUs, or I can say we need Colab Pro or something like that. But yeah, this thing can be done with GPT and T5 models basically. uh, Even OCR is nothing, I can say. If I'm having an image and it has a text, then I need to determine the text now. Firstly, that image will gonna go to any of the CNN model, and I need to do the fusion at that time. I'm gonna combine two of the models, I can say. Or even with the help of NLP task only itself, I'm gonna extract that the text from the image, and I'm going to determine whether the text is good, bad, the polarity of the text. Because after extracting the text, it doesn't matter from where it comes, whether it comes from the tweets or the comments from the any of the e-commerce website, I can say. It basically nothing is for us. For the NLP task is just a text, and we will gonna apply all the things which we have, and we will gonna analyze its sentiments, its polarity, its subjectivity, whatever we need to do, whatever we need to classify, or whatsoever. And the very I'm not saying the last one, but yeah, from this figures, the options or the applications which we are having for the NLP, uh, that is conference resolution. It is a process of finding a relational links among the words, like how the words are related to each other, what are the relations between the words. As we discussed, all the random words are put together to form a sentence because they have the relations with each other. They have some dependency values. We saw that dependency tree, and they have the dependency values and all that. So using that, we can do even for this conference resolution. Now Stanford having their wrapper, I can say, the framework, that is core NLP, if I'm not wrong. You guys can note it down. You can use that. At least you can explore that library, that framework, very easily. So now these are the most important libraries if you want to work with NLP. Of course, sklearn or any basic thing is required, like to read a file, pandas is required. That's not a part of our discussion, I can say. And we know all that things, but NLTK is the most important one. Hugging Face, Hugging Face having all the models, I can say all the high dimensional models which have billions of parameters, millions of trainings can be done. They all are the pre-trained models, and we are having the pipelines for them. Suppose the BERT is there, the GPT is there, T5 is there, Code GPT is there, GPT 1, 2, 3. All the all the huge models are there. Nowadays you guys know, maybe if anyone is using VS Code, that person might know that Copilot. Okay, OpenAI introduced the Copilot concept. What is Copilot? Copilot is nothing, it is our, I can say, our friend who will gonna, who will gonna suggest us ki what I can write after this. If I am defining a function, what I can write after that, what are the parameters I need to uh, put, what is the function I am going to. If you write anything in a comment, suppose in a comment you write, to add two positive integers, or to add two float numbers, whatsoever you wrote, to generate a function for a Fibonacci series, whatsoever. So if you wrote that kind of thing to a GPT model, to GPT-3 or to code GPT or to GPT-J also, it will gonna give the function, the coding function to you using NLP. This is the magic, I can say, of the NLP. Even it is not only used for Python. We can do this thing for JavaScript, for Go, for C hash, for C, for C++. There are lots of languages. Even the code summarization. If you are having, a long function and you are not able to understand what is happening in that function, no, you can use that code summarization and all that stuff. Okay, so these are the amazing examples, I can say. Only few of amazing examples. We don't have that much time ki we can discuss all the examples, because the demonstration is still pending. So let's come to the demonstration part, I can say. Let's begin with that very firstly. I hope my screen is still visible to everyone, right?
Yes, yes, it's visible.
Yeah, okay. So in the very first step, what we will gonna do, we will gonna load the libraries. We will gonna import the NLT and text block, which is the two most important libraries for us. Then let's import all the important libraries. That is nothing, the pandas, the numpys, and to as we want to remove the stop words, we will gonna download all the stop words in the corpus it have, like if we are using for English and all that. Okay, then we need to import the plotly to do the visualization of the, I can say, to analyze the data. Then we have TF-ID vectorizer, as we discussed. We have having that from sklearn dot feature extraction. We have the text blob feature library also from here, and we will just calculate the, to calculate the everything. We have having this NLTK, the most important one. Let's wait for a sec, I can say. Once the kernel is connected, we can implement the rest of the things. I think it will gonna take few minutes only. Once, as we know, this is the very basic step to load the libraries. We know that if we are dealing with machine learning problem definition, or if we are dealing with deep learning, any of the things, if we are dealing, or whether it is NLP, like anything, the this importing library is one of the most important, or I can say the very first step uh, in our in our case, or I can say in our domain, or in our demonstration. So once we are able to load this library, what is the next step we will gonna do? We will gonna load the data. Okay. So for loading the data, okay, for today, let's take the example of Amazon review. As we know, the Amazon is e-commerce website. Everyone is buying something on every day from there. They are having their grocery, medicines, and all that sections. They are having furniture, everything, like they are having, or anything we are getting from that. We will gonna review that product, basically, as we used to do in our daily lifestyle, I can say. So this things can be done once we having the comments, or I can say our feedbacks. So what is this data? This is the Amazon review data set. We are having two files, that is the review file and the item file. So what I did over here, I basically give the path to the review part. I'm sorry, to the review file and to the item file, and nothing else. We just load the data, and for the pre-processing thing, we took few of the columns from them. Okay, once we extract that thing, we can see the data, I can say. Why it's not running? Yeah. So as everyone can see, you know, we are having the data with ourselves. Just a second. Let's go upward little bit to have a look on the data with which we are dealing today. So this is the data file which we are gonna deal with. It will take some time to execute, I can say. I think we should start from the beginning. Okay, the kernel is not started. We need to restart the kernel. Let's go upward to the very first cell, I can say. I think my screen is okay, my internet is working perfectly. Yeah, the kernel is restart. Let's import all the libraries once. Okay, again the kernel is failed to start. Just wait for a few seconds, I can say, or else we will discuss the code. It's connecting with the kernel. Let's see if it is happening or not. Actually, if we connect with the kernel now, you guys can see the outputs on a runtime, I can say. So you can see how tokenizations and how limitizations and how stop words are removing, how we are, you know, getting the outputs actually. Let's try once. If we are having, like, if we are able to connect with the kernel. I hope it will connect, or else we will discuss the code. Okay, so till then, let's discuss the you know, the final review, and the next file is the item review which we have. So basically, if we are applying the pre-processing technique to that, okay, so what will gonna happen? As we discussed, the very first step to, you know, to pre-process the things is to convert the text into lowercase. So over here you can see what we did, the clean text which we have after removing, you know, the things, we will gonna convert that into lowercase. Once we will gonna convert that into the lowercase, the next step, if you remember from the presentation we had, from the discussion we had, we will gonna remove all the punctuations from the text. Once the punctuations will be gonna remove, after that what we will gonna do, we will tokenize, like we will gonna apply the tokenization. This is how the punctuations are gonna remove. Basically we just, I'm just having the function for that, to removing the punctuations, and in a same manner I'm having the function to tokenize, for the tokenization I can say. So it's nothing, as we know the tokenization will gonna split. So we are having that thing, we are having that function, that is re dot split. Re is the thing that is the regular instructions. It will gonna return the words into, from the whole sentence I can say, from the whole corpus. And what we will gonna do, we will gonna store that over here we are having, like we are over here, we are generating the columns in a data itself, and that is clean text tokenize. Now from that once we are able to tokenize the things, the tokenization is done. What we will gonna do, we will gonna remove the stop words. The, as we know, what in the above cell, as we know, it download all the stop words from the corpus for the English language, and from that it will gonna do the matching, the word matching I can say, the application which we discussed. It will gonna do the matching, and it will gonna just remove all the stop words. It will gonna clean. And once we have the pre-process data I can say, after that we can visualize the difference between data. So this is how the data looks. Okay. Suppose in the beginning we the columns which we have the verified column, whether that review is verified or not. We have the review text, we have the votes to that, we have the rating to that, and now we have the clean text. The review text is the dot data, the clean text is the pre-processed one. Now the clean text is tokenized. So what we did in that, we will split the whole sentence into small words. Now the clean text without stop words we have. And once we have that without stop words, even we have one thing, that is clean text tokenized in a joint text. So the all the splitted words are joined together without any punctuations. So once we have that, what we will gonna do, we will apply the feature engineering technique to that. And in this now we are dealing with Amazon review now. So over here we need to calculate the polarity and subjectivity to all the tweets, or to all the text, the review text from the Amazon itself. So the polarity and the subjectivity is gonna calculate it. Polarity will gonna lie from -1 to 1, and if it is -1, that means it has some negative impact, and if it is positive impact, that will be gonna of course 1, and the 0 defines the neutrality of the text. If I'm getting polarity with nearby 0, so that is nothing. It states that my data is having neutral sentiments I can say. Now the next thing is subjectivity. The subjectivity output will be gonna lies within 0 and 1. Okay, so basically even if it is 0, that means we can say it has high subjectivity. You can see from the from this data frame which we got after calculating polarity, subjectivity and everything. Basically in the beginning we have the clean text, the raw text in the beginning, then we clean that text. We are having the rating for each and every text. We have the clean text which is tokenized, and after that we are also having clean text without the stop words. We also having the clean text which have the tokenized words, but in a sentence form I can say, without splitting the words. Now we calculate the length of the words having in a one text, or I can say in a one review. We calculate the count of words. Once we have the words, we calculate the polarity and the subjectivity for each and every review. So once we are able to calculate the polarity and subjectivity, we are able to, to analyze the things. We are able to apply the classification. The classification can be done with, with bias function, with nominal function. Like we can do text classification with anything after that we want. Even we can apply, text for text classification, we can apply BERT also. So basically this is how the pre-processing and feature extraction techniques are helpful in terms of NLP, I can say. And even for data analysis, if you guys want to see, we have the ratings for every review, right? So we can analyze what is the average rating, which we are getting for every text, or I can say on an average. And what is the mean value, what is the review is, how review is directly related with the length of the count, that is count of the words, I can say the length of the words, the count of words in every review. Even we can calculate, the votes which we have and the rating, how they are related with each other and everything. So once we are having this things now, once we did the analysis portion, that is part of EDA. Once we did this pre-processing and feature extraction, once we calculate the polarity and the subjectivity, we can basically do the classification after that. It's just a part of that, I can, the text classification. If we want to classify the reviews in positive, negative and neutral, if I'm having 3 classification classes, uh, if I'm having, 5 classes, that is highly positive, positive, neutral, negative and highly negative, or I can say slightly negative, slightly positive and also. So this is how the classification can be done using this. Okay, even if you want to see the classification, we can let's, I hope my screen is visible to you.
Yes, it's visible.
Yeah, correct. So let me do the full screen to it, and we can also see the classification over here. Basically nothing, we just having the text, I can say, in the beginning. And once we have the text, okay, once we have the text, we will just gonna apply the feature extraction, the pre-processing, everything, the TF-ID vectorizer, and we can apply the classification, the multinomial and NB, that is naive bias. And before that, as we know, by using machine learning and all that stuff, we know that we need to, we need to split the data in a text, sorry, in a training and testing form. So this is what we will gonna do in classification also. Firstly, we will gonna, load the libraries, that will be gonna the very first step for every model training or every pre-processing, anything. So firstly we will gonna load the libraries, then we will gonna load the data. Of course, to do anything, the data loading is required, right? Okay. um let's do the full screen thing over here firstly, so we can see the things in a better way. Okay, so once all the libraries are loaded, we can load the data. And once the data is loaded, what the next step we will gonna do? As we know, we will gonna do the pre-processing, right? So once the pre-processing is done, in this thing, in this example, I can say we are having the same example. We are taking the same data, that is the review file from the Amazon itself. And basically we will gonna use that same data for the classification. We will gonna, drop the missing values from that. If it has any value, that is, if anyone remember, we are having this column that is clean text, tokenized, joint text. So, from the clean text, the tokenizations words will be joined and form a sentence, and we have that data. So we will gonna use that column, we will gonna use that data, and we will gonna check whether we are having any missing values. We will gonna having three classes. In that we will gonna do the classification. The first is positive, the second is neutral, and the negative one. So if it returns 1, that is negative. If it returns 2, that is neutral, and if it returns 3, that is positive. So this is how the data is splitted into the classes. And once we have the data, we will gonna split into X and Y. That is our training and testing. The Y is our feature. The X is our data. We will apply TF-ID vectorizer over there. And once we are having that, we will split into train and testing. And once we have the data, the one is training, that is 80%, the testing, that is 20%. We will having this uniform ratio. Always we used to took for even for machine learning, for deep learning. So same, in NLP also, we will gonna use the same ratio. And after that, we will gonna train the model. So in this scenario, I am using logistic regression without class imbalance. So as I'm the data split I am having is having some imbalance features. So I can say the positive classes is having high, having few more examples compared to, I can say, the few more data points compared to negative and neutral classes. So this is how the things are happening. Once we are able to calculate the the precision, the recall, the F1, and the accuracy and everything, the Cohen kappa, we can analyze how much good the model is and how much bad it is. So whether we can rely on this model or not. Once even we have the confusion matrix, the same way we have for the classification using machine learning. If we are calculating logistic regression for that, if we are calculating for SVM or anything. And as we know, we discussed it with for imbalance class, we discussed it with the balanced class also. And so we can do the result analysis, we can do the experimental analysis using as much as models we can try. It is advisable to try as much as model which are suitable with your problem definition, by applying different features, by doing hyperparameter tunings and all that stuff, so you can choose the best model. This is how the model selection is done.